I am going to explain polymorphism in Java. Polymorphism means having many forms. Poly, the meaning of poly is many, and morphism means forms. There are basically two types of polymorphism. The first one is compile time polymorphism, and second one is runtime polymorphism. There are basically two types of polymorphism, compile time polymorphism and runtime polymorphism. Compile time means whatever polymorphism takes place at the time of compilation, that is nothing but compile time polymorphism. Again, what is the exact meaning I am going to explain, don't worry. And it is also called as early binding or static binding, you can say, or static polymorphism, you can say. And runtime polymorphism is also called as late binding or dynamic binding or dynamic polymorphism. Okay. Method overloading comes under this compile time polymorphism. Overloading and method overriding, that comes under this runtime polymorphism. See, method overloading means multiple methods having same name but different arguments. Those arguments should differ in type or number of arguments. Okay, for example, suppose in any class, there is a class test, and inside that I am writing two methods. Let public void then add, and here I am writing like int x, int y. See, here you can write that for whatever code inside that method. This is the first method, suppose, and same method I am writing again like public void and here add. The name is same, but it is taking three arguments, suppose of type integer, int x, int y and int z. Getting? This is the concept of method overloading. Method overloading means multiple methods having same name but different arguments. In case of method overloading, the method signature should be different. Method signature means the name of method and arguments whatever you are passing. The return type may vary. If both methods are having two arguments, two integer arguments, and here first method is having return type void and second is having integer, then it is not allowed. See, methods should be differentiated according to the arguments, not according to return type. Suppose I am writing one add method is having void return type, and second add method I am writing having C. These are again having two. This is again having two integer arguments, but here I have written int. Then this is not method overloading. This is not allowed. This is just like we are redefining the same method. Okay, means according to return type you cannot differentiate two methods. Always keep in mind. Method signature is part of method. Means just name of that method and arguments. Name of method and arguments. See, there is no any difference in this. No difference. Both are same. Here they are differing according to return type. But this is not valid, this is not allowed. Here these two methods are not considered as two different methods, those are considered as the same. Because method signature should be different. Signature means name and argument should be different. Getting? Here only consider name of that method and arguments. Here again name and methods. Here both are same. This is not a method overloading. Here compulsory at least you have to add one integer argument or you have to change data type of this. Like suppose here we are writing like float x and float y. These two methods are different because this method is taking two float arguments. This method is taking two integer arguments. That means these two methods are two different methods. Getting? Just only consider name of that method and arguments. Don't consider return type. It may be anything. In case of method overloading, Don't consider return type of that method. The method signature should vary. Signature means only name of that method and arguments. Here you are passing two integers, here you are passing two floats. Whether you are returning float or void or anything, it doesn't matter. Here you can write anything as per your need, but here they should vary. Means here you have passed two integers, here you are passing two floats. Okay, fine. Whenever you will call like this, let I am calling this method. See, these two methods are instance methods. That's why we have to first create object and then only we can call these methods. Now see, in the same class I am writing main. Okay, then public static void main string args. Now here we will create one object of that test class. How to create object? Simple, test t1 equals to new test. Now suppose I have called like t1 dot add 5 comma 2. Of course these two are integers, that's why automatically this method will be linked. If you are calling like t dot add 7.5 comma 1.2, then this method will be linked because you are passing two float arguments here. Now what is this? Here automatically this will be linked. Here automatically this method will be linked. Getting? This is the concept of method overloading. Here whatever you are catching that result inside any variable you are displaying or not. If you are returning, then you have to catch that result inside any float variable and then you have to display over here. Or you can write the same statement inside system.out.println again. How? You can write like this. See, it SOPLN 5.6 plus 2.3 equal to. And here I want that this method should be called. Then I will call like t dot add and pass 5.6 comma 2.3. This is nothing but method calling. Here we have directly called, but whatever result we are displaying inside this system.out.println, directly here we are displaying that result. This is nothing but method overloading. Automatically this method will be called. Now whatever linking of this method call to the method signature, that will be done at the time of compilation only. That is the task of Java compiler. Whenever you will compile that Java program using Java C command, then this linking will be done automatically at the time of compilation only. The compilation is the first stage and then next execution is the next stage. Compilation is early stage, execution is a late stage. That's why this method overloading concept comes under this compile time polymorphism. It is also called as early binding or static polymorphism, or static binding also you can say. Getting this point? This is the concept of method overloading. Always keep in mind while doing this, function signature should be different. In case of number of arguments or as per data type, those methods should differ from each other. Then only you can do this. You can achieve this method overloading. See, here you can write any number of methods having same name, but all methods should have different arguments. Now here actually these are considered as a double, but this double can be converted to float easily. That's why this method will be called. Getting? This is nothing but method overloading. Same method name for multiple methods you have to use. One more point is there, you can write here static also. Public static void. Here again public static float. Then you can call this method using directly class name dot. There is no need to create any object of that class. Now here I will not write like this. I will directly call like test dot add. Here also test dot add. Getting? This is nothing but method overloading concept, that is also called as compile time polymorphism, early binding or static binding. Getting? Now just see runtime polymorphism, and there we have to use inheritance concept compulsory. Only runtime polymorphism is applicable for inheritance. Means there should be any base class, there should be any derived class, then only you can see this concept. See, here in only single class we have to write multiple methods having same name but different arguments. Here not like that. Here there is a base class, let this is a base class, and from that you are creating any other class, means you are just extending that base and creating one derived class. Let there is one method named add. Same method if you are defining inside derived class, then that is the concept of method overriding. Okay, and there is not like that the method signature should be different. Here method signature should be same in this. Okay, now how to achieve that, everything I am going to explain now, that method overriding concept. Now see, the next is method overriding. Now how to achieve this in Java? In C++ we have seen this method overriding. There is again same concept, that if base class and derived class both are having same method, same member function, then that is called as a function overriding in case of C++. The same concept is here, like, but here we have to call like method overriding because all functions are a part of class, and that's why all those functions we have to say like methods. Now here there is a base class, and from that we have created any derived class. For example, let there is class base, and inside that I have declared one method, let void m1. I am not passing anything to that method, no problem. And here suppose we have written like system dot out dot println, and here I am writing in a base, or you can write here base method called, anything. Now here I am closing that class. Now I want to create a derived class. Then how to create? Simple, let name is derived. Here B should be capital, it is always better. Okay, derived, then extends base. Now this is a derived class of this. Now see, here again I am redefining this method. See, redefining any base class method inside derived class, that is the concept of method overriding. Means if you are redefining any method in a derived class which is already defined inside base class, then that is the concept of method overriding. Redefining means the same method we are defining here. Okay, now simple, void, then let m1 again. Here we are not passing any argument in this base. Here also compulsory, it should not take any argument. If you are writing any method like m1 having arguments, then that is not method overriding. Then that will become method overloading. Getting? Now here, suppose I am writing like sopln in a derived. This is the concept of method overriding. Simple, base class and derived class both are having same method. Both methods should have same method signature. It is compulsory. Method signature means name and arguments. In both means in base as well as in derived, method signature should be same. Then only you can achieve this method overriding. Suppose I am creating one more class here, class test, and here we are writing that main. Okay, like public static void main string args. Now see here, I want to create one object of base. Okay, how to create object of base? Simple, I will use again base reference, base object, everything same. Simple way is there, base, let B. B is the object of this base class equals to new base. Simple. Now I am calling that method like b dot m1. Now which method will be called? Base method will be called. Here see base class, see reference is of type base, object whatever runtime object, see always this will executed at runtime by JVM. Okay, here we are just creating that object using yes, that is dynamically. All objects will be created dynamically. Means this one, this reference will be created statically. Okay, now this is a reference of type base, object is of type again base. That's why of course base method will be called. Simple. Next, suppose I am creating derived object. Derived, let D equals to new derived. Now suppose I am calling like d dot m1. Now d is having two methods. Actually here we are overriding this method. Okay, now here always remember that whenever reference is of type D, object is of type D, then of course derived method will be called. Okay, now here which method will be called? Base method. Here derived. Now next, see, we have already seen that, see, base reference can hold derived object. Means what? See, suppose I have written like this, base, let b1 equals to new derived I am writing. Reference is of type base and object, actual object, whatever we are creating at runtime, through JVM this object will be created at runtime, but that is of type derived. Base reference can hold address of any derived object. See here actually reference means what? It is just like a address. Now here inside memory the base is b1 and object is of type derived. Now this is pointing to this derived object and this is just a reference of base type. Now which method will be called? Here derived method will be called. We are overriding this m1 method here. Here reference is of type base and object is of type derived. Here normally the priority is given to the reference type, but in case of method overriding always this will be considered. Now see, first step, whenever we are writing like this, first compiler will act here. First compiler will act because this will be created at the time of compilation. Then suppose we are calling like this b1 dot m1. Then compiler knows that b1 is of type base. Then compiler will go inside that base class and will check whether there is any m1 method. If that m1 method is present inside base, see, if that m1 method is present inside that base, then no problem. It will just give a signal that now everything is okay because reference is of type base. If reference is of type base, then that method should be present inside that base. Always remember. See, if we have not written any method like this m1 inside base and we have written like this and we are calling that m1 method, then of course you will get error. Because see, we know that here derived objects method is object is of type derived, that's why method from derived class is going to be executed. But it is compulsion that that method should be present inside that base. Then only this is applicable. Means that method should be overridden. Then only this is applicable. Okay. Always keep in mind, if you are using base reference and object is of type derived, in that case first compiler will check that whether that m1 method you are calling that is present inside that base or not. If that is present, then everything is fine, then that compiler will generate green signal. Means yes, it is okay, everything is fine. Then next JVM will work. Because JVM will always prefer objects, runtime objects. That's why JVL will check. Object is of type derived, then JVM will just go inside the derived class and will call derived method and execute that derived method. But see, always there is a compulsion that if you are using that base reference, then that method should be already defined and that should be redefined inside derived. It is compulsory. If you are not defining this method and you are just defined this method and then you are using like base reference and derived object, then you will get, definitely you will get here error. Getting? Now this is always compulsory that that method should be overridden inside derived, then only you can call in this way. Now here whenever you will call like b1.m1, that JVM will call at runtime this method. Getting? This is m1 and will give you like in a derived message. This is the output here in derived. And this is nothing but again dynamic method dispatch. Dynamic method dispatch means which method is to be called, whether from base or whether from derived, that is totally decided at the time of execution by JVM, and that's why it is called as dynamic method dispatch, and that is nothing but method overriding. In case of method overriding, inheritance should be there, then method should be method overriding should be there, and then only this type of implementation you can do, and then only you can call that method in this way, means using base reference and object of type derived. This overall concept means whenever you will call like this, then method inside the derived class will be called automatically by JVM at the time of execution at runtime, and this overall concept is called as dynamic method dispatch. Getting? And this is again called as a method overriding. In method overriding, that there is a dynamic method dispatch. See, if you have written like this only, then this is not dynamic method dispatch. This is just a method overriding concept. But if you are doing like this, then that is dynamic method dispatch. Getting? Because here base type reference, base type object, normal base execution will be there. Derived reference, derived object, normal derived, means everything is everything is fine, everything is clear here. But here in case of this, always, see, normally always preference is given to the reference. But in this case, whenever methods are overridden, then of course the preference is given to the object type, means this runtime object, not reference. This is the concept of method overriding, and this is the concept of dynamic method dispatch. Getting? Any doubts in this? There are some rules that you have to follow while doing this method overriding. There are some rules that you must know. The first rule is about, see, you know that the method signature should be same. Okay, that is nothing but name of that method and arguments, whatever you are passing, those should be same. Both methods should have same method signature. This is the first point. Now the second point is, in case of this, see, suppose here this method is returning void, this method is returning void, no problem. Okay, but see, suppose this method is returning object and this method is returning again object. Now what is this object? See, here from this method I am returning just null. Null means no any reference. Okay, see, what is this object? Object is a name of the class which is the base class of all classes in Java. That class object you are just returning, but there is nothing of type object, that's why I am returning null, no problem. Now see here in this derived, again same return type we have used, no problem. Here everything is same, method signature is same as well as return type is same, again no problem, it is fine. But see, if you are writing here something else, capital VOID, see, there is a void class again. Just like a wrapper class, there is a void class again present. This is, sometimes it will be considered as a part of wrapper class, sometimes it will be considered as a individual object. Okay, there is inbuilt class in this java.lang package, that is a void class again. That void means just like this, void. Okay, now here you can write void and you have written here object. Now see, if you are writing like this, see, we know that all classes in that java.lang package, whatever defined, all are derived classes derived from object. Okay, all are derived classes of object class directly or indirectly. Now see here, this void class is again derived class of object. See, void is again a class, just like a wrapper class that is derived from object. It is allowed that you are writing any derived class here. Getting? Simple rule. You have mentioned that return type of this method as a object, and here you have defined return type as a void. Now this void is a derived class of this object class, that's why it is okay, it is fine, it is allowed. If you are writing return type same, then no problem, it is normal, it is okay. But this is also okay, but to 1.4 version this is not valid, but from 1.5 this is valid. Only keep in mind, here in base class method, if as a return type you have mentioned any class name, And then the derived means whatever overridden method, inside that whatever return type you are mentioning, there you can write child class name of that class. See, this object is a base class in that java.lang package, and here that void is a derived class which is derived from that object class. In this base class you have defined this method, and here as a return type you are mentioning object as a return type. Then here you can write object as it is, no problem, then it is fine. Also you can write any derived class name as a return type. That's it, simple. Okay, one more example I am giving here. See, object, suppose you have written here, suppose I am writing string. I want to return one string from this. Here you can write anything. Suppose now, just now I am writing null, because I don't have, I have not created any string object here or nothing. I have written null, simple. Now see here, this is having object as a return type, this is having string as a return type. We know that string is a derived class of object class that is present in java.lang package. Okay, we already discussed about that. Now see, here I have written object, here I have written string, no problem. Getting? Suppose you are writing here string and here object, compiler will give you error, definitely. Because here this is a base class and this is a derived class. Here also you have to follow the same rule. Means whatever return type you are mentioning, the same return type you can mention, or whatever return type you have mentioned in derived class method, that should be at least derived class of base class return type. Always keep in mind this point. Okay. Now the next point is the third rule, that is for modifiers. See, here I have not written anything, then that's why here access modifier is default access modifier. See, I have written, suppose here like this, private void m1. In this case, method overriding is not allowed. Means if base class method is having private access modifier, private access specifier, then that method you cannot override. Cannot override means you cannot redeclare in derived class. Method overriding is not applicable for private methods. Always keep in mind. Now the next point is, see, suppose I have written here like public final. See, you know that final keyword is always used to restrict the inheritance, means again overriding also. If you have declared that final keyword while declaring any class, then that class will be the final class that cannot be inherited. Means you cannot create any derived class from that. If you have defined any method as a final, means that method cannot be overridden. You cannot override any method which is defined as a final. You can call that method, no problem, but final modifier will restrict that method from overriding. Always keep in mind, means that method cannot be overridden in derived class. This is very much important. And now the next one is abstract. In this way, suppose you have created any abstract class. Abstract class can have abstract methods as well as normal methods. No problem will be there. Suppose this M1 is a abstract method. Public abstract, suppose I am writing. Now this M1 is a abstract method. See, we know that abstract class, we cannot create object of abstract class. That should be compulsion. There is a compulsion that you have to just derive that abstract class. Compulsory, because we cannot create object of any abstract class. That's why compulsory you have to derive that class. You have to create any inherited class from that, and then only you can use that class as a base class for any derived class, and you can create object of that derived. Any method of a class is abstract, then you have to define that class as abstract. Any method, suppose this is a one method inside this class and this is now abstract. Abstract method you cannot call, means abstract method is having no any implementation. Getting? Means it is a bodiless method always. That's why we will write like this. If any method is abstract, then its meaning is like that there is no any implementation for that method. Now if any method is abstract, that should be overridden in this way. Means see, we have seen that abstract keyword, abstract methods and classes. While learning that, we have seen that abstract methods should have implementation in derived classes. Means this should be implemented in derived class. Getting? Means here see, we have already defined here that M1 method, but that is abstract, and we are providing implementation for that abstract method in derived class. Getting? Means abstract method you have to compulsory override. This is the rule. A final method you cannot override, a private method you cannot override, but abstract method you have to compulsory override. Getting? This is very much important point. Here you cannot create object of this base. See, here you can create reference. See, in this way you can create reference, but this is not allowed now. You cannot create. That's why you cannot call again even this. Okay, now here this is perfectly valid. This is perfectly valid. You can create reference of abstract class, but you cannot create actual object of that abstract class. Here these are some basic rules that you have to follow while doing polymorphism, that runtime polymorphism, that method overriding. Whatever method you have written inside base, that is overridden method, and the method inside derived is called as overriding method. Just keep in mind these terminologies.